as a professor at the Boyce Thompson Institute and also as an adjunct associate professor in Cornell's School of Integrated Plant Sciences. Sarah continues to live in Ithaca with her family, and we're really glad she's still here. Sarah has won numerous awards, but I'll mention just one. In 2021, she received the Borlaug Communication Award from CAST, the Council for Agricultural Science and Technology, and that's a big honor. We're grateful that she found time to speak to us this morning about COVID, climate, and crops, why the world needs GMOs. Please use the chat function to post questions for Sarah and also to try to be the first people to get the right answer in the quiz that she's going to present during her talk. So now over to you, Sarah.
Thank you so much, Lisa. It's so nice to be here. Can you hear me okay? Give me a thumbs up if you can hear me. Great. Yeah, so nice to be here. I can see already in the chat that not only is my mentor Lisa here hosting me, but I see other mentors that I've had over my time at Cornell with us today, Peter Davies, Tony Shelton, and probably others. So it's so nice to be here with all of you. As Lisa said, I was honored to win the Borlaug Cast Communications Award last year, but I'll say that just Tuesday, the new 2022 award winner was announced, and I'm happy to say it was another Cornellian. So Martin Wiedemann from Food Science is the 22 winner. So sharing that news with all of you. And as Lisa says, I was at Cornell for a long time, first as a graduate student and then on the faculty. And today am at Pairwise, which I can tell you a little bit about later. But I want to just acknowledge that a lot of the work that I'll be talking about today, it's like my clicker isn't going to work here, really is based on work that I did when I was director of the Alliance for Science. A lot of the data that I'll share with you today is from the work that the Alliance for Science has done. And so if you aren't familiar with the organization, but you're interested in this topic, I would encourage you to Google up, as my kids say, Google up the Alliance for Science and find ways to get involved in the work that the Alliance for Science continues to do today. So as Lisa alluded to, we're going to start with a pop quiz. You all are retired professors. You've given your share of pop quizzes. It's the end of the semester. We had slope day this week. So let's celebrate with a pop quiz. I'm going to ask you 3 questions. And the first person to get the answer correct, these are going to be multiple choice, I'll send you a copy of one of my favorite books on this topic of GMOs. We've got Mark Linus's Seeds of Science and Pam Ronald and Raul Adamczyk's Tomorrow's Table, 2 great books that I will send over snail mail for your summer reading pleasure. Okay, so let's get ready for the first question. These are very, very tough questions. Okay, so here's 4 vegetables, fruits and vegetables. And the question is, which one of these is not available on the market today as a GMO anywhere in the world? So which one of these is not available? Oh, Tony got the answer correctly. All right, correct. He's a pro at this. He's correct. Tomato is the answer. And this is, this may come as a surprise to many, because if you Google GMO, oftentimes the image that comes up is a picture of a tomato with a syringe in it. And that's very misleading because there are no GM tomatoes on the market. And we don't do genetic engineering by sticking syringes into fruits. So Tony, you are correct, and you can text us in the chat whether you'd like Pam's book or Mark's book, and we'll send it to you. Okay, great. Well, we can deliver it to your retirement party next week. We can save the postage. All right, so Tony, you've already won a prize, so I'm not going to have you answer the next one because I know you know the answer. But let's get to the next question. Okay, in which state is home, which state is home to the only U.S. land grant institution, land grant college, where a scientist has used genetic engineering to develop a genetically engineered crop that has reached the hands of farmers and benefited the farmers directly. Oh, Peter Davies, another pro, has got the answer correct. B, New York. Dennis Miller also has the answer correct. Text me which copy of which book you'd like. Dennis, since your answer technically was correct and different from Peter's, I'll make sure you get a book too. All right, now the answer is New York, of course, and this is the story of the genetically engineered virus-resistant papaya that Tony has actually written quite a bit about. So I can share some additional reading and share the piece that Tony's written about this, unless he wants to add a link in the chat. But this is the work of Dennis Gonsalves, of course, who was a plant pathologist at Cornell up at the Ag Experiment Station, what we now call Cornell Agrotech up in Geneva. And he used the then relatively new tools of genetic engineering to protect the papaya from the ring spot virus, which is one of the most devastating pests and devastating problems that affects papaya globally. Okay, so for those of you who haven't won a book yet, this is your big chance. This is our last question in our very difficult pop quiz here. Okay, so here's 4 products that you might see at your supermarket. And you'll notice that they all have something in common. They all have this label on it that says non-GMO verified with a little butterfly on it. So we have Himalayan fine pink sea salt. We have Himalayan fine pink salt, I should say. We have coconut water, hot dog buns, and hot dog buns are primarily made out of wheat. And we have bacon. So the question is, which of these products that's labeled non-GMO verified has a genetically modified equivalent on the market? Okay. We have one answer. Anybody else who hasn't won yet want to answer, venture a guess? All right. Peter's answer is correct. None of the above. So, you know, obviously there's no genetically modified water or salt because there's no DNA in water or salt, but nor are there genetically modified pigs or bacon or wheat on the market. And so when we walk through the grocery store aisles, we often see this label non-GMO verified, but very rarely is there actually a genetically modified equivalent or analog to these products. So essentially we're paying a little extra for a label that doesn't really provide much information. Okay, so that was our simple challenge for today. And now I want to dive into a much bigger challenge. And that is this challenge here, the challenge of feeding our growing population that's estimated to reach close to 10 billion in 2050, while at the same time reducing the current impacts of agriculture and food production on the environment. And indeed, agriculture is a major contributor to climate change. By some estimates, it produces or is responsible for almost 1/3 of the world's greenhouse gas emissions. It's a major contributor to other greenhouse gases like nitrous oxide. It has a devastating impact on our waterways. It's a thirsty process, and it is a major driver of deforestation and global topsoil loss. And so it has a huge impact on our environment, and yet we can't live without food. We have to produce the food to feed the many, but we need to do it in a way that has a much lighter impact on our environment. Okay. Now, in addition, not only does agriculture affect climate change, but of course, climate change impacts our food system and impacts our ability to produce food. So with a changing climate, we experience now erratic rainfall, very intense storms. We have an increased atmospheric CO2. We have record-breaking heat, persistent drought, desertification. We have rising sea levels. We have increased incidence of flooding. All of these environmental outcomes of climate change have severe impacts on agriculture. These climatic changes impact the severity of the diseases that we see on our crops. It impacts yield, and it even impacts the nutrition content of our crops. We see lower amounts of zinc, for example, iron. We see lower amounts of protein in our crops in a changing climate. And so it really is a conundrum, if you will. Agriculture is affecting climate change. It's accelerating our changing climate. And in turn, climate change impacts agriculture. It makes it harder for us to grow the food that we need. And it also lowers the nutritional quality of the food that we're growing. And so it's a very complicated problem. The world is changing. We no longer can rely on the agricultural methods of our grandparents or of previous generations. We have to use new technologies to do agriculture better. We have to change the way we think about producing food in this time of tremendous change and tremendous challenges. Okay, so if we go back to this figure of all of these ways in which agriculture is having a negative impact on our environment, it gives me hope that the tools of biotechnology are already helping to address each and every one of these insults of agriculture on the environment. And I'll share with you some examples. And I'm going to kind of ignore the chat here. Tony shared the article about Hawaii, which thank you so much for sharing that, Tony. But Cynthia, if there's anything that comes up that should be raised immediately, I'm going to ask you to sort of jump in and interject. Okay, so let's go through some of those applications. Already today we have applications of BT technology, which is a technology that both Tony and Lisa worked on extensively in their career, where you can essentially take a gene from a soil bacterium, that's where the BT name comes from, Bacillus thuringiensis, engineer it into a plant, and the plant then can protect itself from some of its most devastating insect pests. And in this case, scientists from across the public sector, funded with funding from USAID and other donors, have engineered cowpea. We might call it black-eyed pea, cowpea, to protect itself from its insect pest, the maruca pest here in this picture. And so this is one application of biotechnology that essentially dramatically reduces the need for chemical use in agriculture and therefore has great environmental benefits. There are research efforts around the world that are using genetic engineering to essentially engineer cereals like corn to produce their own nitrogen in association with bacteria so that they no longer have such a need for nitrogen fertilizer. And of course, nitrogen fertilizer is dramatically overused in our agricultural setting here in the US. But in other parts of the world, the problem is very different. There isn't sufficient access to nitrogen fertilizer, either because it's not available or because farmers can't afford it. So this has been long held as one of the holy grails of plant science. Can we, use engineering to equip crops to be able to take care of their nitrogen requirements independently of synthetic nitrogen fertilizer? And great progress is being made to this end. This is not something that's ready for prime time yet, but there's a huge global effort underway to achieve this goal. Researchers in China and Sweden have engineered rice so that it produces much less methane in the rice paddy setting. Again, lowering the impact of rice production and lowering the amount of methane that's produced in these agricultural settings. There's the application of biotechnology to promote conservation agriculture. This is having an amazing benefit on lowering carbon emissions in agriculture. So in using this technology, you essentially eliminate the need to plow and till the soil, which has two great carbon offsetting impacts. So one, you aren't running tractors over massive acres of land across Brazil, Argentina, the US, Canada, and other places where this technology has been adopted. But also, when you don't till the soil, of course, you don't kick up that stored carbon and release it back into the atmosphere. And so this has had a tremendous impact on lessening the amount of carbon dioxide emitted in agriculture. There are a number of different applications of biotechnology that really promote sustainable intensification. The idea that we can grow more with less, whether that's less water, less land, less resources, right? And so we can conserve more of those resources for other purposes. We can conserve water, which of course is going to be one of our most delicate and scarce resources as we move into the future, already is in many places today, and conserves land for other purposes so that we can promote biodiversity and use less land for producing food. So there are all of these applications of biotechnology that really have wonderful environmental impacts that can really help us produce more with less, and that can help us reduce agriculture's negative footprint on the environment. But of course, we all know that this so-called GMO is controversial in some corners, and has maybe not quote unquote lived up to its potential. And indeed, that's something that I hear from many critics, that genetic engineering has not lived up to its potential. GMOs have not lived up to their potential. And this is a point that, I tend to agree with the critics on. They may be right. Perhaps biotechnology has not lived up to its potential, particularly in agriculture. And so, why do I say that? Well, there's 190 million hectares of GM crops being grown around the world. And if you look at that whole sort of, pie of genetically modified crops, 99% of that is comprised of just 4 crops. So soybean comprises 50% of that, maize, 30%, cotton, 15%, and you add canola, you're up to 99%. And so only 4 crops have really benefited from the technology. And then if you look at the traits that are out there, roughly 99% of all GM crops on the market are improved with just 2 traits. We have herbicide-tolerant traits. We have insect resistance through BT, the work that Lisa and Tony have contributed to. And then we have combinations of those 2. So essentially, we were talking about 4 crops and 2 traits. But what about all of the other crops that are out there that are important for people and their health and their livelihoods, culturally important foods that are important in, across the developing world that might not be globally traded commodities? What about all of the traits that you can imagine that could have, been engineered into these crops? You can think about crops that help with, post-harvest quality, crops that increase nutrition, crops that have a longer shelf life and could reduce our food waste, which of course is another environmental problem. So in effect, the critics are right. This technology hasn't lived up to its potential. And there's all kinds of reasons why that's the case. And I would argue, and we don't have to get into this at this very moment, but I would argue that that's not due to the science. In most cases, it's due to social issues and politics. Okay, so that said, GMOs are all around us, right? 29 countries grow 190.4 million hectares of biotech crops. 43 additional countries import biotech crops. So, this is a widely adopted technology, both in the industrialized countries, but also across the developing world. So developing countries actually grow more biotech crops compared to industrial countries in terms of area. And it's been a widely adopted technology. It's probably one of the most quickly adopted technologies in the world. Once the policy environment is in place, farmers choose to adopt this technology. And in many places of the world, such as the US, Brazil, Argentina, and Canada, and India, when a biotech crop becomes available, the adoption is so rapid and so widespread that it really almost reaches saturation. In India, in the case of cotton, in the US, in the case of all four of those key crops. If we look at the contribution of biotech crops to food security, sustainability, and climate, there's some really compelling numbers that have been produced by economists like Graham Brooks out of the UK. So from 1996, when the GM crops were first commercialized, until these data were collected in 2018, you see farm income gains as high as 225 billion generated by biotech crops. We see the contribution that these crops have made to reducing the amount of chemical use, 776 million kilograms, Graham Brooks estimates. We have the promotion of biodiversity, again, growing more on less land, conserving more hectares for other purposes like conservation, reducing carbon dioxide emissions. Graham estimates that this 23 billion kilograms of carbon dioxide is equivalent to removing 15.3 million cars off the road for 1 year. And of course, as we'll hear in a few minutes, it's really impacted the lives of farmers and their families by uplifting their lives, creating job opportunities, income, etc. So contributions of biotech crops have impacted our lives in lots of different ways. So, we hear a lot about misinformation these days. In fact, it might be one of the biggest challenges that we're facing today. And it's, it was the word of the year in 2018. We've heard a lot about misinformation over the last 2 years as we've struggled through this pandemic and navigating the information around vaccines and the spread of the pandemic, et cetera. But in plant science, the scientists like Tony and Lisa and Peter and others who are on this call, they've been dealing with misinformation for 3 decades around this topic of GMOs. So the science is pretty clear on the safety and the utility of genetic engineering and biotechnology. And yet there's still today is quite a bit of misinformation out there about this technology, although I would say that it's decreasing in volume and impact. So when the pandemic came just over 2 years ago now, it really sort of, a lot of the misinformation we were hearing around COVID, was reminiscent of misinformation around biotechnology. And so my colleague Ed Mabaya in global development and a medical doctor from Nigeria, Dr. Nosiffor, and I published a piece in The Conversation, essentially applying the lessons we learned from misinformation around GMOs to COVID-19, particularly in the African context. And certainly there are a lot of lessons that we can learn from our 3 decades of battling misinformation on GMOs and apply to other issues like COVID-19. And that's exactly what our team did. So at the Alliance for Science, we were used to moving around the globe and, conducting trainings and doing lots of science communication out and about. And then the pandemic came and we were all sort of hunkered down in our various homes around the world. And we thought, wow, how can we do something to, how can we use our tools? How can we contribute to this tragedy that's happening before us? And so, we've been tracking the conversation and the misinformation around GMOs for a few years since we founded the Alliance for Science. And we thought, well, maybe we can apply the tools that we've been using to track misinformation and describe the misinformation landscape around GMOs and apply that to COVID. And so we did, in partnership with our our partners at Cision. And we quantified the sources and the themes in the COVID-19 infodemic. And what we did is we essentially, working with Cision, looked at 38 million pieces of English language traditional media from the period January 1st, 2020, and through the end of May 2020. And we saw that about 3% of that total body of media that related to COVID had some kind of misinformation around COVID-19. And when we looked at that body of misinformation, we saw that actually 16% of that was fact-checking. So that's great. That's journalists doing their job. And we saw that more than a third of it was misinformation that had a connection with the then president of the United States, the president that preceded Biden, and that there were really these 11 major misinformation topics that sort of dominated the misinformation landscape. And so this is sort of what the misinformation landscape looked like over that time. You can see, you remember if you go back 2 years, what was happening in that time. We were trying to understand, the origins of the virus. We had Anthony Fauci, out there in front, trying to help communicate about it while dealing with tensions in the White House. And then, of course, you had the biggest spike during this period, which was the president himself at a press conference in April talking about the role that disinfectants could play in treating COVID, which, of course, was a major driver of misinformation during this time. So there were, again, 11 subtopics that sort of dominated the landscape. The pandemic, misinformation around Anthony Fauci himself, 5G, Bill Gates, bat soup. You've heard them all during this period, but the big one was really around miracle cures. And that's the sort of turquoise line there that sort of, blows everything else out of the water. That was by far the most dominant misinformation theme. And in fact, it comprised more of the misinformation around COVID than all the other topics combined. And so when we talk about miracle cures, we're kind of aggregating in that bucket misinformation around the role that UV could play, or antimalarials like hydroxychloroquine, disinfectants. And so this all kind of comprised what we call the miracle cures bucket. And much of this misinformation was driven by association with the then president of the United States. Okay, so that was the COVID-19 story, and in fact, we submitted it for publication, probably in the summer of 2020, and it was taking a really long time to get through peer review, as academic publishing does. And then, it seemed sort of like, urgent that we get this information out there. So we ended up pulling it from peer review and giving the study to the New York Times. And they ran a piece, I think it was October 1st. It was like the day after the first presidential debate, sharing the story of what we found with COVID misinformation. And since that time, we've also done a study looking at the misinformation landscape around COVID vaccines. Again, using these tools that we'd used to track misinformation around biotechnology, but now looking at vaccine misinformation. And when we look at traditional media, actually there's very little misinformation around vaccines, which is great. Now the social media situation is a different story entirely. But when you look at traditional media, most journalists are doing good reporting on vaccines. So we have a paper coming out shortly. It's been submitted, approved, and ready to go in the British Medical Journal. And the conclusions really were that there's not a lot of misinformation around vaccines in traditional media, but the biggest misinformation themes that do exist are around safety, and also, interestingly, around the speed of their development. So people were skeptical of the vaccine because of how fast it was developed, which of course, we would expect vaccines to be developed faster today using the tools that we have at our disposal, using biotechnology, much more so than vaccines that have been developed earlier in the last century. Okay, and of course, during this time, we saw great examples of really good science communication. People like Dr. Fauci, so proud to have him as a Cornell alum, out there really trying to get good information out to the people at a really critical time where, getting good science-based information really did make the difference between life and death. But it wasn't just sort of high-profile people like Dr. Fauci who were inspired to get out there and do good science communication. We also saw scientists, all over the world sort of, take on the call of duty to get good information out to people. And I'll just share one example. This is Rob Swanda, who was a PhD student at the time. He's since finished, was a PhD in biochemistry. And he made a simple video on a whiteboard for his parents to explain how the mRNA vaccines work. And he posted it onto his Twitter feed, and it went viral and had tremendous impact. In fact, if you look at his Twitter feed, you can see that the government of Canada actually used his video and gave him kudos for doing such great work. And of course, it was written up in the Cornell Chronicle. So it's just a nice example of how, we don't have to be professional science communicators. We don't have to be high profile figures like Dr. Fauci. Anyone can get out there and, spread good science-based information. And we have so many tools today to do that. Okay, so I want to link this COVID story back to biotech and GMOs. And what we saw in 2020 was really interesting. We saw in this 2020 news cycle, we saw less coverage of GMOs. People were talking about other things, believe it or not. We're living through a pandemic. But what conversation there was in media about GMOs was very positive. And part of that was that people connected the role that biotechnology played in developing these life-saving vaccines. And that had this sort of positive halo, not only on medical biotechnology, but also on the GMO conversation across the board, which of course includes agricultural applications. So this is kind of a busy slide here, but it essentially shows the favorability and the sentiment of the GMO conversation from 2018 to 2020 and how it changed over time. And I'll just direct your attention to the second row, what's traditional media. And you can see that from 2018 to 2020, the conversation improved in favorability from 76% favorable to 80% favorable. But overall, it's been a pretty favorable conversation. Reputable journalists working for mainstream media outlets, have long sort of recognized the value of GMOs. They've long recognized their safety and the scientific consensus around their safety and utility. Social media can be a little bit more of a Wild West show, and you can see that, back in 2018. And so now we're going to move down to the third line there. And we see that in 2018, the conversation on social media is still a little erratic. Into 2019, lots of up and down, 60% favorable. And then in 2020, it gets extremely favorable, as favorable as in traditional media. And so this was a really interesting observation that even in social media where anybody can jump in and, be an expert, the conversation actually turned quite favorable. And then that lower series of bar graphs there is the sentiment. So red is negative, green is positive, yellow is mixed, so has negative and positive in the same story, and gray is neutral, which we consider to be favorable. Okay, so again, the visibility of GMOs decreases on social media in 2020. People are talking about GMOs less. They're talking about other things. They're talking about the global pandemic. But the sentiment itself is much more positive. And what we see and how we explain this is that we saw a decrease in this sort of anti-GMO conspiracy content, likely due to a shift in those organizations focusing on COVID conspiracies. And I'll show you some examples. So if we look at who the top Twitter accounts were in 2018 and 2019, we see a pretty similar picture, right? Some of these, the ones in red are known sort of anti-GMO accounts that speak negatively about GMOs. And we see some of the same organizations popping up in 2018 and 2019. Okay, so these have the most reach, the most impact on Twitter. But then when we get into 2020, we see a very different picture. A lot of those organizations have fallen off the map. They're not talking about GMOs anymore. For example, Farm Fairy Crafts, which has been, the top in 2018, the number 2 spot in 2019, falls to number 10 in 2020. And many of the other ones aren't even in the top 10 anymore. And once those organizations are no longer talking about GMOs, you see much more reputable sources like Reuters and CNN and the New Scientist actually taking position in that top 10 sort of influential category on Twitter. So these organizations who have been, clamoring on about GMOs in previous years are no longer talking about GMOs in 2020. So where did they go is the question, right? What did they start talking about? And, when you go and you look at these accounts and what they're tweeting about in 2020, it takes us back to our miracle cures story. So it turns out all of those organizations who were talking so much about GMOs in previous years, in 2020 have gone to essentially peddle miracle cures and sell products to treat COVID. And so it showed us sort of two things that we had believed for a long time, but it sort of started to provide a line of evidence that many of these groups that spread misinformation about one topic, like GMOs, might seem unrelated to other topics like vaccines, but it turns out that they're all sort of related. and the other piece is that we've long said that, peddling fear about GMOs is a moneymaker. And when it becomes more of a moneymaker to peddle misinformation and try to sell miracle cures, then people shifted to the miracle cures, which was much more lucrative and impactful for their business than talking about GMOs once we were into 2020. So it's just interesting to see how these different groups are connected. Okay, so the second part of the title of my talk was why we need GMOs. So I'd like to try to make the case for that. I want to share a story, and this is a story that is very much a part of Tony Shelton's career. So Tony was, his retirement it was this year, and we're celebrating it next Friday. But of course, he tried to retire earlier, but he couldn't because we had one last job for him to do, and that was to ensure that this eggplant that had been developed using biotechnology had impact and was being responsibly deployed and benefiting farmers in Bangladesh. And so, again, this is a story that's very relevant to Tony's career, but it made a huge difference in the lives of farmers like this gentleman here, Muhammad Milan Mia. He's a farmer in Bangladesh, young guy, and taking up the challenge of agriculture in very difficult times. So he was one of the first 20 farmers in Bangladesh to get access to this genetically engineered eggplant. This is a GM eggplant that's been engineered, again, with that BT gene that protects the eggplant from devastating insect pests. And this technology was approved by the Minister of Agriculture, the woman on the right here, in 2013. She was a ardent supporter of biotechnology, wanted to ensure that this technology did not bypass Bangladesh, did not bypass the farmers of Bangladesh, And so she exerted a lot of political will to make sure that this technology was something that Bangladesh could benefit from. So in a very ceremonious fashion, the first 20 farmers received seedlings of this eggplant that had been developed at the Bangladesh Agricultural Research Institute. And those farmers were able to plant that in 2013 and then reap their first harvest in 2014. Okay, and Tony is the entomologist here, and he can talk about this in the Q&A that follows. But eggplant, to grow eggplant requires a lot of insecticide. Farmers spray their eggplant crop 2-3 times per week, as many as 84 times during the cropping season. And so this is a very intensive, pesticide intensive crop. You can see here the fruit and shoot borer, doing its damage that it does to eggplant in this picture. And so the whole point of this application of biotechnology is to render these fruits sort of self-protecting, right? They no longer need insecticide. They can protect themselves from the fruit and shoot borer. Okay, so no longer need to use these insecticides that we know are damaging not only for the environment, but for human health. You can see here a real lack of personal protection equipment by the people applying these sprays. Okay, and so Milan was among those first farmers who grew this crop back in 2014. And fast forward to today, or even a couple of years ago, Tony and his team sort of went back out to the field and talked to these farmers to find out, like, well, how did it go, and what are the impacts of this technology on your lives and on the environment? And the data that come back are actually quite compelling. So just to give you two of my favorite numbers from the studies that Tony and others have done, well, we saw overall a 62% reduction in insecticide use, which is dramatic and good for the planet. And importantly, we saw a 6-fold increase in farmers' income. Okay, so that 6-fold increase is a dramatic, life-changing increase in income. That's the difference between a farmer making the average $3 a day and making $18 a day, which is absolutely transformative. And it's transformative for the entire family, right? I mean, if you look at Milan's daughter, this picture was actually taken, several years into his growing BT eggplant. And, she's got her nice dress on, her new barrettes, she's holding a mobile phone. She's connected to the world, and she's going to have opportunities that her parents never had. So, one technology, one application of biotech, the determination of a lot of people from Tony Shelton to the Minister of Agriculture in Bangladesh having tremendous impact on real people's lives. Okay, so, biotechnology, including GMOs, is good for people and it's good for the planet. We have environmental benefits that I detailed at the beginning of the talk. We have economic and livelihood benefits that you can see through the case of Milan. And yet, we all have to work together, again, to, keep pushing back that misinformation around biotechnology and so many other topics. It's on all of us. Particularly, people with the kind of credibility and reputation that you all have to get good information out there. And there's so many channels at our disposal today to do that. So I want to share some examples from Africa where, there's so many great technologies being developed, particularly by the public sector. Cooking bananas that are resistant to disease, the cowpea case that I shared earlier. So many good products being developed, but in many environments, still lacking the political will and the sort of policy environment that needs to change before farmers can actually benefit from these technologies. And a lot of that has to do with activism that is essentially imported from places like Europe and the US. And I wanted to share a video of Patricia Nanteza, who was a fellow with the Alliance for Science in 2015, just sort of candidly telling her story about the impact of that activism, and then, sort of finishing with her core message, which is essentially in all of her communications is always, hey guys, let us speak for ourselves. Let Africa speak for herself. Let us speak for ourselves. We have different problems than you, and we need different solutions. So I'll share that video as we wind down here.
Scaremongering that is seeping into our countries is basically fueled from USA or from Europe, and I sort of understand like where they are coming from. They are speaking from their own point of view. I hear in France they have very little pretty gardens, and then they can walk around and pick out weeds. You wake up on a bright Saturday morning, and then you put on your pretty purple gloves, and then you go and you're picking all this manure and taking pictures and posting on Facebook. They are saying everyone should have a little pretty garden where they're not using any modern seeds. They should farm the way their grandparents farmed. And they're saying that because for them, gardening is a hobby. That is not farming in Africa or in Uganda. We farm to get food. We farm to get an income. And this is our livelihood. It's not like some sort of hobby. My message to people in the US and Europe is please realize the extent of your decisions. It doesn't stop with you. It goes all the way to all continents of the world.
So there's a message for all of us. Okay, I just want to end with some notes of optimism. I'm at my core an optimist, and I do think, and I've argued in other venues that the GMO debate's kind of over. People can choose, farmers can choose whether or not they want to grow biotech crops where they have the policy environment to do so. People are less concerned about it. People are talking about it less. Journalists are covering the topic less. And meanwhile, the technology that is available has been quite successful. And even in Europe, Europeans aren't really, it's not top of mind for them. They don't really care about GMOs anymore. Their reported concern by this Eurobarometer decreased enormously from 66% in 2010 to 27% in 2019. And I would guess that if you looked at a future Eurobarometer, it will continue to decline as people recognize the important role that this technology has to play in producing the food we need to produce in a sustainable way in light of our changing climate. Some other sources of hope: we have some new approvals, some new crops being approved around the world, particularly across the developing world. That gives me great hope. So a sort of a homegrown, homemade pinto bean approved in Brazil recently. That eggplant that has had such a great impact in Bangladesh is now approved for food, feed, and processing in the Philippines. Again, work that Tony's been leading. And golden rice, which we've heard about for a couple of decades now, is finally approved in the Philippines, and will soon be able to have the impact that it's to have, it was always meant to have, on vitamin A deficiency and the associated diseases that stem from vitamin A deficiency. So again, one of our first examples of a biofortified crop really reaching its intended beneficiaries. So really exciting new developments. And of course, it also gives me hope that, yes, we have these tools of genetic engineering. They're important, and they'll continue to be important. But we have new tools today that are different and potentially, much more impactful. The tools of gene editing. Many of you have heard about CRISPR, and CRISPR, of course, is a new technique. It's different from genetic engineering, and it's going to allow us to, again, breed much more climate resilient, healthy, nutritious crops that will help us feed the population while at the same time lessening impact on the environment. And so for me, and this gets to, why I moved to Pairwise, this startup that's very much focused on a mission to increase fruit and vegetable consumption. For me, the next frontier is really, how can we use these technologies to benefit consumers and to benefit, the health of regular people? So many of the first generation of biotech crops and GMOs were really about corn and soybean. But, there's no reason not to use these tools to develop new varieties of fresh produce that are exciting for consumers like you and I. And that's what we're doing at Pairwise. We're using CRISPR to essentially make more accessible, make more desirable, really healthy fruits and vegetables like super greens and blackberries and so forth. And so that to me is an exciting new frontier. And I look forward to joining your series sometime in the future and telling you more about how we're doing that. Okay, so with that, I think the challenges before us are enormous, and it's time for us to open our minds to technology that can help us solve these big problems around feeding the population while at the same time protecting the planet. Thank you so much for your time, and I look forward to a lively conversation. I'm going to open up the chat here. Sorry if I spoke and carried on for too long.
Okay, thank you very much for that, Sarah. We've got a question in the chat. Can you see that?
I can, yes. Okay, so we've got a comment. Please address the issue of Roundup Ready GMOs and also give examples of false information that is out there. So yeah, Roundup is a big topic. Roundup is an herbicide that's been used in, so it's an herbicide. It's not a GMO. It's an herbicide. It's a chemical, right? And it's used in combination with seeds that are resistant to Roundup. So if you plant your field and you plant it with a Roundup resistant seed like corn or soybean, typically, you can essentially eliminate weeds by spraying Roundup, and then the plants that are resistant to the Roundup still grow and thrive, but the weeds are eliminated. And this, again, has eliminated the need for a lot of tilling. So it has some environmental benefits, and it displaced much more toxic herbicides that were used prior to the advent of Roundup. But it's gotten a lot of bad press. It is safer, and it persists in nature far less than what the previous herbicides did, and so in that way, it's an improvement over what was used in the past. However, it is overused. It's been a really good technology for farmers. They like it. It makes their life easier. It makes their profits higher, and so they have adopted it very rapidly, and now it's overused, and we see weeds developing resistance to Roundup, which of course, presents new problems. So you have to deal with those resistant weeds. And so, there's no magic solution, right? And I think, the overuse of Roundup is really just demonstrates and is evidence for the need to continue to fuel innovation, right? We can't get complacent when we have one good solution. We need to continue to invest in innovation so that we can do agriculture better. Okay, we've got another question here. I've often seen by some the challenge to GMOs and other tech issues is that it isn't natural. Have you seen that as an argument in your experience? Yes, absolutely. It's not natural is one of those arguments that people that say, like, I don't want to eat a genetically engineered crop because it's not natural. I would argue that nothing about agriculture is natural, right? It's absolutely, everything about agriculture is about man's intervention or human intervention, right? So yeah, there's nothing natural about agriculture. But that said, crop improvement is even traditional means of crop improvement that we've been doing for thousands of years is not natural, right? It's about taking two plants and crossing them and doing traditional plant breeding is manipulating the genetic outcome of the progeny. And so, biotechnology is just sort of one plant breeding tool. Genetic engineering is one plant breeding tool on a whole spectrum of different types of plant breeding, none of which are natural, all of which sort of modify the genome. But that said, if people, choose not to want to eat genetically engineered food or food developed from crops that are genetically engineered, then that's everyone's prerogative, right? And so, choice is really important in this conversation. Thanks, Norman.
Sarah, I wanted to point out that Tony Shelton made a couple of contributions to articles as well.
Not to mention the entire field.
Did you want to speak about that at all?
Yeah. So Tony worked for many years with Dennis Gonzalez up at Cornell Agritech and wrote a great piece about the whole genetically engineered papaya story, which when I talk to students at Cornell, I always say, you can't graduate from Cornell and not know about this great contribution of Cornell to the world of agriculture. And so Tony's added a link to that piece in the chat. Encourage everyone to read it. It's a great story. And it looks like he's contributed a couple of others. But the other major contribution, I don't see any links here, but Tony's, oh yeah, here he is. Cynthia Robinson also has posted at 11:20 a.m. the story about the BT eggplant that's chronicled online. So again, Tony's done a great job of really documenting these big success stories, and both the eggplant story and the papaya story, of course, have a real strong Cornell connection. So work that we can all feel proud about.
I also posted a link to Tony's page so people can look at that as well. Thank you.
Right. Sarah, do you think if we get past COVID at some point, some of these organizations will turn their attention back to GMOs or move on to something completely different?
Well, I think so let's split these organizations into two groups, right? So we have a lot of environmental NGOs that are science-based who already, over the years, independent of COVID, have really changed their views and their outlooks on biotechnology. They've revisited the science, the decades of science. They see the role that biotechnology can play in addressing bigger challenges like conservation, right? Controlling invasives. And so groups like the Environmental Defense Fund, the Nature Conservancy, they get it. They understand the role that biotechnology can play in helping the climate. So they're the ones that they're guided by the science. And then there's groups that, claim to be environmental organizations that aren't looking at the science. And those are groups, I would say, that kind of follow the money. So if, peddling miracle cures is where the money's at, then that's where they are. If, spreading fear about GMOs is where the money is, and that's where they're going to get their donations, then that's where they're going to be. And so, whether GMOs will be a moneymaker for them post-COVID or not, it's hard to say, but I think increasingly it won't be. People just they feel like they've been duped. They're excited about CRISPR and newer forms of biotechnology. They see the role that they can play in helping human health, eliminating diseases, curing diseases, and helping us protect the planet. So I feel optimistic. But again, I wouldn't aggregate all environmental groups into the same bucket, because you've got some really good science-based groups that are doing great work that have been supportive of the role that the technology can play.
Great. Do we have other questions for Sarah, either in the chat or if you want to ask to be unmuted or something?
Hi, Lisa. There was one question come in from Norm Scott. Are you seeing CRISPR as being less resisted than GMOs, both in past and present?
Absolutely. People are excited about CRISPR. It's a new technology. It's a new era, and it's a new generation of people making sort of societal decisions, right? And when we look at if media is any indication of like the broader societal outlook, the conversation around CRISPR is very positive, both in traditional media and in social media. In fact, in 2021, the conversation around CRISPR in social media, where anybody can be an expert, was actually more favorable than in traditional media. So it's a very positive conversation. Young people are excited about the role that it can play in innovating in food. We have a really, interesting food culture right now. People are using tools of biotechnology to, come up, really promote plant-based diets and provide alternatives to meat using biotechnology. So there's just so much innovation in food, and these are consumer-facing benefits that consumers can interact with directly. And so the conversation is very favorable. And not to mention that CRISPR is also being used to address major, health issues, sickle cell anemia, for example, and so many other diseases. And so, it's very much a different starting point than where we were back in the early 2000s. And I think in general, people are so focused on the climate emergency that these other issues are much less top of mind. And also any tool that we have that we can help address climate change, young people are so motivated to address the climate crisis, and CRISPR certainly will play a role there. Great. Well, I'm going to put my email in the chat, and I'm always happy to talk about this topic. So if you have any other questions that come up later on, feel free to reach out. And I thank you again for your time. I hope those of you who are in upstate New York enjoy this beautiful day that we're having. And take care, everyone, and be well. Thank you.
Thank you so much, Sarah.
Thank you very much, Sarah.
Thank you, Cynthia.